Hello and welcome to another video. This time we're going to be looking at registers, variables and memory. There's no code with this video, it's just a theory session, a bit of a refresher on what registers are all about and how they're different on the Agon. In BASIC we're quite used to having variables of various types such as strings, integers and floating point numbers. In assembler we don't have that. We define pieces of memory to store data, whether that be ASCII characters or numbers. We've used examples so far in our lessons where we've included a label to indicate where that data is stored in memory, and sometimes terminated in a 0. Other times we've had a start label and an end label to define where that data is stored. But at the end of the day, it just ends up with bytes being stored at various points in our memory. We can define those bytes in different ways depending on what size of information we're storing. If we're storing single bytes, then the command .db with one or many numbers afterwards defines bytes of those values. If we want to store a word, that is 2 bytes, then we can use the command dw. Similarly, if we want to store a long, which is 3 bytes, we can use dl. Another useful one is ds. That defines a string of bytes. In this example, a string of bytes, there's 32 of them, and they're each going to contain 255. When it comes to the registers on a Z80 chip, there are a number of registers we can use. They're called A, F, H, L, B, C, D, E. All of those store 1 byte. Some of those can be joined together to form a 16-bit pair, which can store a larger 2-byte number. With the 8-bit registers, A is the one that you most commonly use for doing calculations or working things out. For example, add A, B adds the contents of B to the value that's in A and keeps it in A. CPH will then do a comparison of A against the H register. The 8-bit register B is often used for counting in loops. If you're used to a for next loop in BASIC, then a similar thing can be done with B using the DJNZ instruction. 8-bit registers are all limited to 1 byte, that is from 0 to 255. Examples of instructions include LDA, 12, which would put the number 12 into the register A. LDB, FF in hexadecimal would put FF, or 255, into B. LDA and then 1234 hexadecimal in brackets would put the value of the byte stored at that memory location into A. LDHL in brackets, A would store the number which is in A into the memory address defined by the value of HL. Another 8-bit register is the flag register. This one we don't usually use as a register on its own, rather we're interested in the individual bits within it. It contains the answers to any of the queries we might have made. For example, CP0 would compare the value of A with 0, and then JPNZ to a label would jump if the 0 flag is not set to a memory address label. With the 16-bit registers, the main three that you'll come across are HL, BC and DE. HL is often used as a memory source, although it can do some mathematical functions as well. BC is often used for counting, for example in the LDIR instruction, and DE is often used as a memory destination, but all can be used as general purpose numbers. 16-bit registers can contain any number from 0 to 65,535. That's FFFF in hexadecimal. The command LDBC 1234 hexadecimal would put that hexadecimal number into the register pair BC. LDHL and then in brackets hexadecimal 1000 would take 2 bytes that are stored at that memory location and put those into HL. There are 2 other 16-bit registers worth mentioning, IX and IY. These are index registers. We've used IX in some of our examples already. An index register provides a quick way of finding numbers that are offset from the base of that index register. For example, LDA, IX plus 16, would load A with the byte that is 16 above the index address. There are two other 16-bit registers which you're unlikely to be using at the moment. PC is a program counter. You can't change this one. It simply tells the system which line of code it's currently working on. The stack pointer is a register which points to where we are currently on the stack. Again, this is unlikely to be useful when you're starting out, but might come in handy later on. But what about our Agon, our EZ80, which runs in ADL mode? ADL stands for Address Data Long. So what does that mean? Well, our Z80 had a 16-bit memory address bus, which means in total it can look at 64K of data at any one time. The EZ80, running in ADL mode, can actually address 24 bits of memory. This means, in theory, it could look at over 16 megabytes of data. What does that mean for us in terms of our registers? Well, 16-bit register pairs are no longer really pairs. Each of our registers that are 2 bytes are now 3 bytes each. Each of our registers HL, BC and DE all have an upper byte. So we have to be careful when we're using our HL, BC and DE registers. We can still address H, L, B, C, D, E as individual 8-bit registers, and we can use them as pairs. We just need to watch out how we're using them. So what we really need to watch out for when we're using 24-bit addressing is that we're no longer storing 2 bytes of data when we put HL into a memory location. In fact, we're storing 3 bytes. If your code is based on original Z80 code, you need to watch out that you're not actually overwriting data where perhaps you've only allowed for 2 bytes in your program.